Milton Smith here. I'm on the AppSec Tools team, which is a team in NetSuite Trust Services. This is a demo on JVMXRay, which is a dynamic analysis tool for Java. It allows you to monitor security events in near real time on any sort of process that runs within a Java virtual machine. But most germane to us is web application servers. Okay, so what is JVMXRay? So JVMXRay is pretty much like syslog for your Java virtual machine. And so what do I mean by that? Okay, so your Java virtual machine has a security model built into it. A lot of people don't use it, but there's permission classes that you can leverage. There's Java Security Manager that you can extend. There's infrastructure in there for implementing a security model or extending one that Java has and customizing it to protect your to protect protected resources or to defend protected resources. And so a really cool aspect of this, though, is that you don't need to make any changes at all to the code that's running on the app server. We're talking about app servers here, and that's what's most interesting to us, but actually any virtual machine. As programs are running on the Java virtual machine, there's a lot of different checking of different events that are happening within the machine. And all we're doing here with JVMXRay is we're basically implementing the security manager, but instead of access or doing enforcement, we just take the metadata that's passed to us about what's happening and what files should be tested or that sort of read access on this file, that kind of thing, and sort of packaging up into an event we're calling. And then doing different things with those events. And that's really what JVMXRay is. And so you sort of get something for free, right? You don't need to make any improvements to your code, yet you can put this agent on the virtual machine and immediately start creating these things that kind of look like a log4j log. But essentially, it's not our app messages that are being logged. It's the security actions against those protected resources that's generated automatically, depending on what sort of resources your app uses. So let's take a look here. All right. So we've got I'm just moving some windows around here. Okay. So you see an X-ray log on your screen. You can see some events. So this was generated on Apache Tomcat. You can see these like property names here, and then you can see what looks like property names over in here that are actually being logged, and that's exactly correct. So as these name properties are being accessed within the system properties, the Java virtual machine or JVMXRay is recording these things as it goes down one by one through each of these properties. And then you can see a permission check here, and then it came from this class in Java called suppress access checks. And then another named property is being accessed here, Java Util Logging Manager. Okay, so probably for Java logging. Access thread group, access thread. There's a lot of different events that are being thrown here. And in fact, it generates these aren't like exhaustive tests, but when I started up Apache with just its general default configuration and JSP pages that it provides and clicked around, it generated like about 65 gigabytes worth of traffic in the first or log messages in the first 45 seconds. So there's an incredible amount of activity in and a web application server that happens even before your application is started. And you might not be interested in that sort of stuff. I mean, maybe you're more interested in only the things that your app is doing. But this is kind of interesting. Maybe if your application infrastructure is executing binaries, those would be sort of things that you'd be interested in know about if your app server is running on that platform. I know I would be. So that's just a small example of the kind of things that you can get. Here's a real log that comes from Apache, and you can see there's a lot of duplicated messages on here, and that's because a single method might be called multiple times, through a series of operations. So that's what you can be seeing here. You see some mbean sort of bean registration stuff here. That makes sense for an app server. And all these rich messages are available right now for Apache Tomcat, but there's some possibility we can get this working with other platforms as well. It just takes a little bit of work. There's as you can imagine, in writing this kind of code, there's a bunch of issues that we've been able to work through as far as chicken and the egg kind of thing. You can there's scenarios where, if you write a file and it generates messages and you read those messages and you record them somewhere, it creates more messages, and you can get kind of in these circular dependency loops here. But we've got most of that stuff ironed out at this point. But yeah, you can see all these rich messages. This is just coming from a default, here's something here they're doing with FTP. That's kind of interesting. Not sure what that property is. But I've always been interested too, like what sort of system properties does Java have, or does Java use, that we don't know about? And this could, not that it's a state secret by any means, but you know how it is. We we focus on the features that we use more often. And things that we don't encounter very often, they could still be useful to us. It's just we haven't had a reason to maybe reach out and see some of these things. So, but anyway, here you go. Here's a lot of different, here's a factory method, kind of interesting here. More class loader stuff. Oh, you can see all these, look at these properties here from the JVM. It's kind of interesting. This JDK.xml, total entity size limit. That's kind of interesting. So clearly there's a whole lot of different settings that are being accessed in here to start up a web server. Let's go down and see some of the last messages that were logged in the file. Well, clearly that's like way down in there. But yeah, okay, yeah, there we go. Oh, that's interesting. And then this destroy Java VM call. So access thread was called, and then it added the metadata of destroy Java VM. So that's kind of interesting. That would make sense, being the last line in the log. But yeah, so clearly there's a lot of different events that are being fired here for lots of different things that are happening, and these are all things that you could you can run the entire stack if you wanted to for JVMXRay, which is the agent, and then intercepting all these different rich messages from your web app server, and you can take those and you can just write them to a flat file if you want to. Maybe for what you're doing, you just want to take these messages out of the VM, log them to a flat file, and process them in your own way. Maybe you want to save them to, like a Hadoop grid or something like that, and run your own pig queries or anything that you want to do. So you can use, part of X-ray, like the code that agent that pulls the information out, or you can use the entire thing and let JVMXRay pull the messages out of your app server and then send them to your back office JVMXRay server, store them in a database there, and then you can extract them and do different things, and do some machine learning against those messages offline. So there's all kinds of cool stuff that you can do and check for, and it's in some ways JVMXRay is a bit of a Swiss Army knife. Imagine like trying to explain the value of a web browser to somebody who's never used one. It's sort of like a little hard. Well, you can look at information in a sort of technology independent way, and you could explain those things to people, but maybe it just wouldn't make sense until they start using it, right? And I think that's kind of the thing here. So JVMXRay is a bit of a Swiss Army knife, and it's sort of hard to understand how all these different messages and things might be used to get information out about a business or access to protected resources that shouldn't be happening, or those sort of things. Anyway, I hope that this is helpful to understand some of the benefits. Bye. Okay, yeah, one final thing here before we move on to the demo. So in case it wasn't obvious to you what the use cases for JVMXRay are, there's probably two larger ones. One is running JVMXRay within the auspices of your Java virtual machine for your web application server. And so getting, all the different juicy information about what the current state of your web app is, and all the things that are going on there and files that you're opening, that sort of thing. The other, use case that we're looking at is using JVMXRay at the, during the test process. So during CI/CD, there's a lot of use cases that companies develop for testing their apps, and those are perfect for JVMXRay, because if you can imagine, really what you want with JVMXRay when you're executing is you want a suite of tests that really represent a good cross-cutting of the features in your profile. Those are the same things that we want for any kind of testing, really. When we're testing our apps, we want to sort of give them as good a test as we can, and hopefully things break when we're testing, so we can get them fixed. And that's really the idea of all these different feature tests that are being done. And yeah, JVMXRay is marvelous add-on, because security is just like any other kind of test. When you're rolling through different testing for quality, and security is really just another quality test. So by adding JVMXRay to your CI/CD testing processes, you're also exercising security at the same time. Now, I guess a weakness of JVMXRay 2 is that, or a strength, can be either, I guess. But one of the things with JVMXRay is if your code isn't executed, well, then we don't see those events fired, so we have no idea. So you can imagine, like other testing processes, if you don't execute those areas of code, or have a test that calls out those scenarios and executes them, then you're not going to see, any of the metadata that comes from them. So code coverage is kind of a concern with these sort of tests for JVMXRay, just like code coverage is a concern for regular testing. And there are a lot of tools that speak to those areas. I don't think code coverage is anything new, and but it's something that needs to be thought about for JVMXRay too. So there's using JVMXRay for CI/CD sort of stuff. To me, that seems like probably the easiest place to start. And if there is a problem with getting some of the nuances of X-ray correct, then maybe it's not such a pressing problem if there are some weaknesses. Whereas obviously running directly in your server's web, right in your runtime, is definitely riskier for you, right? If something happens. So probably CI/CD is the initial path that people would benefit from, and then of course the more mature all your different test cases are, and that you've defined on your in your CI/CD suite, the more compelling those cases are and exercise all the different features of your app, you would then receive more benefit from JVMXRay, because as all those different APIs are called and those cases are exercised, it will fire lots of different types of events. And so if an app is behaving mischievous in a way it shouldn't be, then X-ray can show those things. So anyway, that's the two major use cases of X-ray before we step into the weeds here. You'll probably be seeing more things that are applicable to running on a web app server, but probably the CI/CD case is the case that'll be addressed first. All right, take care, bye-bye, and hope you enjoy the demo. Okay, so shown on the screen here is a little boxy diagram. Shows web application server on the left, JVMXRay server on the right, and sort of how a web application generates these events, and they go through filters and event processor over the internet to the JVMXRay server and processed on the back end. So for the purposes of this demo, we'll just be showing the upper left-hand box. So it's we'll show some dynamic filtering. We'll show an event processor that's pretty basic. It just takes events and writes them to a flat file, one of those text files shown in the block diagram, and that's about it. It keeps the it's perhaps not the way that you're going to run it in real life, but it does help with testing and development. Makes the setup easy just to see what you're going to get out of it, how a server works, what type of events you get. And then once you get a little confidence that things are what you like, you can enable the JMS side of things and have a more robust framework. But in any case, some of the JMS infrastructures currently on the home path here to being completed. It actually works, but I still need to put a few more features in there and stuff to get it something that we can use. In any case, we'll be focusing on the X-ray agent. Let's just take a look at what's in the file. So we ran it. Let's click around a little bit more here. So let's go over, click execute a few of these different servlets. All right, now let's switch over. And let's tail that event log that we just looked at. So of course we're gonna miss some stuff in there. Let's show that on the screen. Okay, so now you can see the event log. If you look at the web browser, you can kind of see part of it. I know I got a lot of stuff going on the Windows. It's busy, but let's just kind of click around at a few different things. We're not really even typing in anything. It's just kind of running these things. You can see some of the events being fired because we're tailing the log. Okay, here's because it plugs into the Java virtual machine. JVMXRay works with any Java that executes on the virtual machine. So in this case, it supports the JSP pages that are running on the sample Tomcat here. So as we click around on these JSP pages, you can see the different events that are being generated. I like to call it near real time. It takes some time to operate. I guess everybody's notion of real time is different. So if I say near real time, it sort of appeases those that are sticklers for definition, perhaps. Okay, so here's a hello world sample tag handler. You can see a lot of events were fired in there. Okay. And what else? Okay, let's take a look at the actual log output. All right. Add a new video source for my log. Okay, log output is available. All right, now I know we're covering up some of the other things that you want to see here too. So hopefully, all right. Oh yeah, okay. Okay, so here's a piece that's a little bit easier to see. So we've got a file write event that's fired from the async file handler in Apache Tomcat, one of their classes. Okay, let's see. So we see our stack trace and the file handler and the async file handler, log entry. Okay, and then we can see the users folder towards the latter part of the event. We can see the user folder, we can see Milton, we can see Tomcat, we can see the version of Tomcat, the Apache-Tomcat-10.0.6. And then afterwards we have some information for the actual file name. So in the 3 metadata fields at the end, you can see there's like this first field is the first of the metadata of the 3 metadata fields. You got this log host dot 2021 1215, and that's the actual file that that Apache wrote. I have no idea what it does, but anyway, you can sort of hoover up all the different file events and see every single file that Apache wrote during this test. You can find out any file it deleted. You can find out where in the code and what actual Java file in the code that this happened to, whether or not you have the source code for that file or not, which is kind of interesting. Okay, in the next section here, what we're going to see is just a little bit of JVMXRay agent configuration. And why that's important is, you remember earlier when I mentioned how it can generate JVMXRay agent can generate copious amounts of information, events within the Java virtual machine if it's not filtered. And so in this next section here, we sort of discuss, how filtering can really sort of cut through some of the noise to get you the information that's most relevant for you. So that's why filtering here is important, so that you can not just filter the needle in the haystack, but reduce the number of haystacks. So that's what's going on here. All right. Okay. So then down here, package define, same thing, no stack traces for those. We're using the filter because we are doing some a little bit of basic pattern matching here with starts with. Okay. So what this is doing is suppressing the JVM messages. So if there is a match, we do a deny. And you can see all these different packages here that are produced. So if the code being executed comes from any of these sort of standard packages that are part of the Java SE core distribution, then all those events are suppressed, but only the ones that have to do with package access and define. So other events like a write event or something, a file write, that would actually be produced. Okay, and then permission. So yeah, any sort of calls to the internal permissions framework for Java, we want to suppress those where they come from, standard sort of Java code that ships with Java here. So there's some things that generate a lot of noise, and for those things, we want to go ahead and just suppress those permission checks. Again, if you like them, you can turn it on if you want to see them. Here for package access, read and class loader create, we use a different filter. We use this null filter, which does not allow for any of these sort of, more rich metadata parameters that you can filter with. So any event match here, any package access, file read, or class loader create, with a null filter will produce a match, and there'll be no stack trace that's taken, And the default action on a match is to suppress it, which is the default action of deny there that you see. And then lastly, the last rule is for any file executes or file writes. Same thing, we use the null filter. We have a full stack trace. So for anything that didn't match any of our other previous criteria, so meaning it's probably at this point some sort of, something in your code, well then, we want to see for file execute and file write. Now, if you have a lot of file writes, maybe you want to handle those differently in a less sort of noisy way. In this test code, I just want to see every file write, and I want to see, for sure, I want to see every file execute. And so I have an option here to include the full stack trace. And then, of course, any match is considered an allow, which forces the event to be logged. And those were the stack traces that you would see in the log file that I showed in the previous demo for file execute.